Cash flow forecasting is one of the most misunderstood and most dangerous parts of construction project management. Projects don't collapse because they run out of profit. They collapse because they run out of cash at the wrong time. If you've ever wondered, how do I build a reliable construction cash flow forecast? What inputs actually matter? How do payment terms, retention variations, and delays affect cash, not just cost? How do contractors and developers forecast differently? What does good look like in real projects? This guide gives you the complete picture. Written from 35 plus years of quantity surveying and commercial leadership experience across major infrastructure, aviation, and building projects, this is the most practical and complete guide you'll find. Let's start with the foundations. 1. What cash flow forecasting actually means in construction. Cash flow forecasting is the process of predicting when money will move in and out of a construction project over time. It's not about how much the project costs, it's about when each portion of that cost becomes cash. Many teams get this wrong because they confuse cost flow with cash flow versus cost flow. Critical distinction: cost flow shows when work is done. Cash flow shows when that work is paid for. Those two things rarely happen in the same month. A contractor might install AED 2M of work in March, but not receive cash until late May or early June. That gap kills businesses. 2. Why cash flow forecasting matters. More in construction than any other industry, construction has unique financial pressures. A. Long payment cycles, 30, 60, 90 and even 120-day cycles are normal. B. Retention, typically 5-10% is withheld and released long after project completion. C. Variations and claims, cash often lags months behind entitlement. D. High working capital requirements. Contractors front load labour, procurement and materials early. E. Delays and EOTs. A delayed project increases overhead, shifts cash projections and reduces liquidity. F. Progress-based cash. Almost all construction payments are based on valued progress, not invoices. In short, construction is a cash business disguised as a profit business. 3. Who uses cash flow forecasts and why? Developers, clients funding drawdowns, lender approval, cash exposure management, CapEx phasing contractors, working capital planning, procurement scheduling, subcontractor payments, risk exposure subcontractors, labour planning, material orders, survival consultants, QS, PM, cost managers, progress valuation, cash projection reports, cost to complete modelling. 4. The 8 inputs. Every accurate construction cash flow forecast requires most forecasts fail because they ignore or simplify one or more of these. 1. Construction schedule, time. Cash follows time. The schedule defines the spine of the forecast. 2. Cost breakdown, BOQ or WBS. You need a structured cost model tied to activities. 3. Procurement schedule. Large package payments, e.g. MEP facade, distort cash curves. 4. Payment terms. Every contract has different rules: 30 days, 60 days, paid when paid. 5. Retention rules. Deduction and release timing massively affect contractor cash. 6. Variations, change orders, approved versus pending, valued versus uncertified, forecast versus actual. 7. Claims and delays, EOT, disruption, prolongation costs, idle labour, all impact cash. 8. Risk allowances. Real projects need scenario modelling. P10, optimistic. P50, realistic. P90, pessimistic. 5. How cash actually moves on a construction project. Here's a simple example. March, contractor completes AED 2M of work. April, consultant certifies AED 2M. May, client processes payment. June, contractor receives AED 2M. That's a 90-day lag and it's conservative. Meanwhile, the contractor pays labour weekly, materials on delivery, subcontractors monthly. This creates a cash deficit for several months. This timing gap is the heart of cash flow forecasting. 6. Forecasting methods explained clearly. Method 1, bottom-up cash flow forecasting, used by QS teams, planners, commercial managers and contractors. How it works: divide work into activities or BOQ items, allocate costs to schedule periods, layer payment terms, apply retention, add risk scenarios, strengths, very accurate works for detailed projects, weaknesses, time consuming, requires strong data integrity. Method 2, top-down cash flow forecasting, used by developers, feasibility teams and lenders. How it works: apply benchmark distributions, e.g. 10, 20, 40, 20, 10, fit curve to project duration, adjust for procurement and milestones. Strengths: fast, useful early; weaknesses: lower accuracy, poor for monthly reporting. Method 3, S-curve forecasting. Every construction project naturally follows an S-shaped curve. Slow start, mobilisation, design, procurement, rapid growth, peak construction, slow finish, testing, commissioning, handover. An S-curve can be built using earned value cost distribution formulas, historical data, planned progress curves. Method 4, risk-adjusted forecasting, P10, P50, P90. Construction always has uncertainty. Risk-adjusted forecasting allows you to model delays, variations, productivity drops, supply chain issues, late approvals. This prevents overly optimistic projections. 7, how payment cycles impact cash flow, the missing piece in competitor guides, progress claims and valuations, the value of work done cash in, the true cycle, work is completed, claim submitted, consultant reviews, certificate issued, client payment processed, cash received. The lag can be 60, 120 days. Retention, typically 5% deducted from each payment, 50% released at practical completion, 50% released after defects. Liability period: retention can trap hundreds of thousands or millions late in the project. Variations and change orders. Cash from variations is often delayed because of disputed quantities, late instruction documentation, slow evaluation, late certification. Forecasts must include realistic timing. Delays and EOT claims. Delays impact cash in two ways: pushes revenue later, increases overhead costs during extended duration. Many contractors fail to model this second effect. 8, building a cash flow forecast, step by step. This is the practical guide missing from every competitor article. Step 1, collect all inputs. Contract schedule, BOQ payment terms, procurement plan, risk register checklist included at the end. Step 2, build the baseline forecast, assign cost to planned schedule activities, create value distribution per month, generate the planned S-curve. Step 3, apply real payment terms. This is where cost curve becomes cash curve. Add certification review delay, add payment cycle delay, add retention deduction, add subcontractor cycle. Step 4, add variations and risk scenarios for each scenario. Best case, expected case, worst case, include additional cost. Additional revenue change in payment timing. Step 5, analyze monthly cash position. Calculate cash in, cash out, net monthly position, cumulative cash balance. Look for negative cash months, working capital peaks, procurement cash spikes. Step 6, build the reporting dashboard. Include planned versus actual cash, cash curve versus cost curve, earned value overlays, forecast at completion. 9, real construction examples. Example 1, contractor on a 12-month fit-out project, work done in April. AED 1M client payment terms, 60 days subcontractor payment terms, 30 days cash timing. AED 1M work done in April. AED 700K paid out in May. AED 1M received in July. May 700K, June 300K, materials plus overhead. July plus 1M, this results in a net 1M exposure before cash is recovered. Example 2, developer on a multi-year airport project. The capex is distributed: year 1, 10%, year 2, 40%, year 3, 40%, year 4, 10%. Developer forecasts include funding drawdowns, Contractor claims interest exposure, delay risk. Example 3, subcontractor with paid when paid terms. If the main contractor waits 90 days for payment, the subcontractor may wait 120 plus days. This destroys cash unless forecasted. 10. The golden rules of accurate construction cash flow. Forecasting use real payment cycles, not contractually ideal ones. Include retention always. Forecast variations and claims realistically. Update monthly at minimum. Tie the forecast to the schedule. Model multiple scenarios. Track planned versus actual continuously. Never assume the client pays on time. Link QS, planning, finance in one workflow. Visualize the cash curve clearly. 11. Common mistakes and how to avoid them. Mistake 1. Confusing cost flow with cash flow. Mistake 2. Ignoring payment cycle delays. Mistake 3. Ignoring procurement spikes. Mistake 4. No variation modeling. Mistake 5. Not updating during the project. Mistake 6. Overestimating productivity. Mistake 7. Not linking QS and planning data. 12. Tools, templates and automation. Excel. Flexible, good for custom projects, requires skill. Specialized software. Better visualization. Multi-project control, audit trails. AI-powered forecasting. This is the future and what you're building. AI can extract quantities from drawings, integrate schedule, plus cost, plus risk, predict delays, generate scenario-based cash forecasts, update cash forecasts automatically based on site data, notify teams of cash risk early. This is where construction cash flow is heading in the next 3 to 5 years. 13. FAQs. How often should I update my cash flow forecast? Monthly during execution, weekly on high-risk projects. How accurate should it be? P50 accuracy is typically within plus 10-15%. What if clients pay late? Model a pessimistic scenario using real payment history. Should contingency be included? Yes, but only in cost, not revenue. Conclusion. Cash flow forecasting is not just a finance exercise, it's a survival tool. The construction industry rewards companies that understand the timing of money, the impact of payment cycles, the cash effect of variations, retention and delays, the power of forecasting scenarios, the value of modern tools and AI automation. If you can master this, you protect profitability, reduce risk, and steer your business with clarity, not guesswork.